Welcome to the series of courses about the concept IBM Watson. In this unit, we will discuss how to build servers that will help us understand some basic concepts of how the IBM Watson work. We are not building a real IBM Watson computer as it will entail a lot of resources. Just the 2800 cores alone is enough to overwhelm us. In here, we will build the basic servers that will support the point of entry of a question, the process it would go through and give an answer back. Since this is no real IBM Watson, these servers do not hear nor talk. Input and output will be the old-fashioned way. You have a screen where you type and the answer is shown on the screen. After completing this unit, you should be able to learn the concepts behind how the IBM Watson uses several computers to complete its tasks. In building each server component, you will see what each does and how completes the IBM Watson thought process. Remember, we are just learning the concepts and not to build a real one, but the concepts will be enough to enable you to build a real one should you decide to do so. Here are the basic server components that you need to build in order to study the concepts of the thought process of IBM Watson. We will discuss each in detail in the following slides. The first server we will discuss is the presentation server. This is where you will write the Java programs that will support the logic and thought process of question and answer. Let us call this the query panel. The query panel is where you deploy the GUI where you will enter your question, process that question and look for an answer. This is also where you will install OpenNLP, the application that will understand the question that was written in the query panel. The answer to the question will now be searched from the NFS drive. In our prototype, all the processed data will be stored in the NFS shared drive. You need to install a Java SDK version 1.8 and above to enable the Java code you wrote to run. The query panel is a graphical user interface wherein the question will be entered and the answer to be displayed. Under the covers, what it does is it tries to understand the question by passing the question to an application installed in this computer called OpenNLP. Once the question is understood, it will search for the answer. Prior to entering a question, you will need to tell the query panel where to get the answers from. We would point the query panel to look for the answer in the network file system drive, which contains results of unstructured data to structured data conversion results from our other servers. It can be a shared flat file, a shared XML file, or a connection to a remote database. We used OpenNLP for this prototype. There are other more complex options like OpenPsych. OpenNLP is an open-source application that can be downloaded from the internet. In our prototype, we will use this to process our question and look for the answer. There is an exercise included in this course on how to download it and how to set it up. In addition, how to create the query panel. When a sentence is received, each words are broken into parts and categorized. In this example, you can see that words are identified. Like John was identified as a proper noun. But there are other words that can be classified in more than one way, like the word saw. It can be a verb or can be a noun, or the word light, which can be a noun, a verb, or an adjective. So how does OpenNLP process this? OpenNLP has built-in components that you can call to dissect, classify and understand the statement. Here is a partial list of built-in components that can be called to understand the statement. The more components that are used, the more the statement is understood. In our prototype, only the sentence detector and the chunker components were used. In the example above, you can see how OpenNLP would parse and classify the words found. The more OpenNLP components you use, the question will be understood better. You need to access the NFS drive from the other servers. This is where the data sets that the query panel look at to get answers to the questions. We have included a lab setup guide in this course to show how it is set up. You will need a Java SDK installed in the system. You need to run some Java programs that you will create for the query panel and OpenNLP. Here are the basic components of the presentation server. Linux 64-bit. Minimum 8 GB RAM. 64-bit capable CPU. 50 GB of hard drive space. Java SDK. Query panel. OpenNLP. Access to the NFS drive. Networked, intranet and internet access. The business logic server is your thinking or analysis computer. In this server, you need to install the Java SDK, Eclipse and the UIMA SDK. Create the UIMA applications to convert unstructured data to structured, such as type description, annotators, analysis engine descriptors, common analysis structure, CAS, Java classes, CAS consumers. The content which is in the form of unstructured data where UIMA will process. You also need to share the drive where you place your processed information to be accessed by the other servers. You will also need a Java SDK installed in this server. Eclipse and UIMA, the two other development components, will also need a Java SDK installed. Eclipse is an open-source Java development environment that will be used with the UIMA SDK to develop Java applications that will form parts of the collection engine that will convert unstructured data into structured data. There is an exercise included to configure Eclipse with UIMA in this course. Unstructured Information Management Architecture, or UIMA, pronounced as UIMA, is an open-source development kit donated by IBM to the Apache Foundation and is downloadable from the Apache Foundation website. UIMA is a kit that will make development of a collection processing engine easier through pre-built reusable objects from within its SDK. This is what we will use to develop the Java applications to create a collection processing engine that will convert unstructured data to structured data, which in turn then be used by our query panel to get answers based on the question posted in it. This is the UIMA architecture. It basically gets unstructured information such as text, video, audio and other forms of unstructured data, identifies, collates and collects these types of information and places it in a CAS repository. Then a CAS consumer reads it, then writes it as structured information. In this prototype, ahead of time, we processed a bunch of unstructured data and converted them to a structured form of data. We used an architecture called UIMA, Unstructured Information Management Architecture, to convert unstructured data into structured data. There are other ways of getting information from unstructured data, but for this exercise we decided to get our answers from data that is already in a structured form. Basically, how it works is, we will use UIMA components to get data from a pool of unstructured data by writing Java UIMA-based applications to tell what keywords we want. The UIMA components will collect them and put it as what is called a CAS, or a common analysis structure. These are the collection of items we want to find based on certain criteria. Once in the CAS, we wrote CAS consumers that will write the data into a structured form such as databases, CSV flat files or XML. This is also where you will create your UIMA applications to create your collection processing engine. These applications are type description, annotators, analysis engine descriptors, common analysis structure, CAS, Java classes, CAS consumers. There are tutorials included in this course to create these. Here are the components of the business logic server. Linux 64-bit. Minimum 8 GB RAM. 64-bit capable CPU. 50 GB of hard drive space. Java SDK. UIMA SDK. Java programs produced from UIMA. Shared NFS drive accessible to the network. Networked, intranet and internet access. The third machine is the file and database server. This is where you will store files that will be needed by the other systems, and it is also where the output of the files will be deposited. You need to install an NFS drive here that can be read and written into by the other systems. There is a course included that shows how to do this. If using a database, you need to have the client software and or JDBC or ODBC drivers to access data needed by the system. Depending on the amount of data to be processed, there may be a need to place a Hadoop system to help balance the workload of the systems in the Concept IBM Watson environment. In this prototype, we used the IBM Infosphere Big Insights Quick Start Edition, which can be downloaded for free from IBM through the Big Data University. There are links to this from within the Big Data University, as long as it is not for production use. Hadoop is built in the IBM Infosphere Big Insights Quick Start Edition and can be used to define each server in the system as nodes. But if we are just processing small amounts of data, this may not be needed. It is still advisable to include this for education purposes. A database can be included in this server, but only if you intend to write CAS consumers that writes to a database. We did not cover this in this course, but for future use or further studies on this, it will not hurt to include it now. Just make sure that this database and its contents are accessible to the network, especially the server running the query panel. This is the typical configuration of a file and database server with Hadoop. Linux 64-bit. Minimum 16 GB RAM. 64-bit capable CPU. 120 GB of hard drive space. Java SDK. IBM InfoSphere Big Insights Quick Start Edition. DB2 database, or any database. WGET utility. NFS drive installed. Networked, intranet and internet access. Here are 3 options to deploy these server. You can use real physical servers. Use VMware ARE images. Or put them in a cloud. Here are some of the things we discovered. Using real servers can be costly to own, costly to maintain, and there might be additional costs to upgrade them. It will also be time-consuming to network all of them. Using VMware ARE images can also be an option, but you will need a machine that can host 3 images running simultaneously plus 32 GB of available memory. You will still need a pretty high-capacity machine to host all 3 images with a large AMOUTN of RAM, 32 GB plus RAM to run the host. The best option is to run this in a cloud. In a cloud, you can request for the amount of RAM and HD space needed to run this in addition to the number of CPUs needed. In fact, in a cloud environment, it is possible to maybe just create 2 servers combining the business logic and database server into one. In our prototype, we created these servers in a soft layer cloud environment. We were able to get the machine specifications we want, adjust them on the fly, not worry about maintaining the servers, not worry about watching the server, uptime and downtime, and avoid all the noise and power consumption had it been a physical server. Once built, this is how it will look like. The query panel is where you will input your question, and it is also here that it will be answered. What it does is, it takes the question and passes on the processing of the question to an artificial intelligence application such as OpenNLP or OpenSci to understand the question. In this prototype, we used OpenNLP. In OpenNLP there are built-in programs that can parse the question, chunk the question, and other forms of processing and classifying words in the question. Once understood, it will call a program to look for the answer. Beforehand, an application converting unstructured data to structured data have processed the data where you will be getting the answers from. The query panel then looks for answers in these data sets based on the question understood from OpenNLP. Once the question is fetched, the answer is displayed back to the query panel. This diagram will show the ultimate server configuration. It shows the components of the presentation server, business logic server, and the database file server Hadoop system. This ends this unit. Having completed this unit, you should have learned the concepts of how the IBM Watson uses several servers to complete its task. Learned about the basic components of a conceptual Watson system. Understood the flow of how a question is understood, documents analyzed, and answer given in the system.